Thank you very much for the invitation today. It's great to be back at the Institute. And I'd like to give now a contrasting but hopefully overlapping presentation from a business practitioner perspective from the world insurance and reinsurance. Reinsurance is simply the insuring of insurance companies. But we're looking here at natural catastrophes and their impact on business and the analytics that supports that, the day-to-day work, but also how things are changing and hopefully opportunities that might arise for some creative thinking. So very briefly, introduction to the natural hazards risk assessment perspective of the industry, focusing on tropical cyclones, a global risk, and the historical data that we look at that. And then a specific question about how can we assign frequency to various scenarios we might be interested in. And then finishing off on the climate change dimension. And again, hopefully this will bring in further opportunities. One point just to begin with is my company, Willis Towers Watson, we have a Willis research network. Very often that's focused particularly on subject matter expertise in natural hazards, seismology, hydrology, atmospheric physics, for example. But in the last year, I've been working with a lot of mathematics departments, including Bath and Warwick, the European study programs. It's somehow harder to get purchase on some of that innovative thinking from maths departments. So to some extent, like the last point, perhaps we're very much focused on the Natural Environment Research Council. We have a lot to do with UKRI in the UK, but how can we try to involve perhaps some more EPSRC perspectives? Hopefully we can flesh some of those out. We've heard about the quiet revolution at the Met Office and forecasting. I think there was an even quieter revolution in the insurance industry from the late 1980s, early 90s. There was very little analytical quantitative work, particularly around natural hazards, but there were a series of catastrophic events, particularly Hurricane Andrew in the US in 1992, very severe windstorms in the UK, 1989, early 90s, that were driving insurance companies out of business. They became insolvent. They had so many claims from that disaster, so many roofs ripped off, for example, that they went bust. And that is a serious problem for society in general and government, for example, as the insurer of last resort. We want much more stability in our financial system. That brought in a wave of analytics into the industry, a business need to quantify that risk in terms of frequency and severity. And the key aspect was having to move from understanding the hazard, as we've seen in Nigel's slides, to understanding the frequency of the losses that come from those hazards. So there's a requirement for data from the industry. We need input data to put into models. And during that time, there was sort of advances in geospatial data. We've looked, again, centrally at that role of the resolution, the pixel size of the modeling. That is fundamental to all of the geographical diversification aspect of the modeling that's gone on. To some extent, there was a wild west of exploring lots of innovative ideas in the early 90s. Relatively rapidly, those mathematical approaches boiled down to relatively formalized processes across the industry for a variety of reasons. One, there was a desire to compare processes. Do we understand it? How can we compare apples with apples? This process also brought in actuaries, curve-fitting folk into the property side of the business. Generally, we're looking at the built environment for our risks. There was also a greater drive for transparency, and this is becoming increasingly important. And I think we'll see that also with when I finish off on climate risks. And of course, there's codification now in regulatory regimes. In Europe, we have IOPA, Solvency II, for example. And so that can be quite constraining, I would say, on creativity. A brief introduction, tropical cyclones. That's a useful term globally. They have different names in different basins. Hurricanes in the Atlantic, typhoons out in Asia, for example. And traditionally our work, obviously we are interested in relatively infrequent but severe events. And this definition, again, we'll come back to look at this. So we were looking at forecasting work in some of Nigel's work. The focus here is much more empirical on trying to establish historical data sets of these relatively rare events. We can see a familiar track of low pressure up in the, here we go, up in the top right. And then we can use various algorithms to define a wind field around that. These gust speeds are the things that we use to calculate damage from that. Yes, and so historical data sets, there's always a limited amount of information. And unlike, say, motor claims, of which there are many, or health claims, whereby the actuaries can go to town with their statistical expertise with a variety, there's a richness of data. Here we don't have that luxury. There are infrequent events, and we are aware that they are only part of a much bigger universe of potential events. So here, for example, to the 2016 hurricane season, a lot of activity out in the Atlantic, for example. Obviously, the key aspect is, do these storms make landfall? Because it's the focus on the impact that we're interested in. Here we can see for a 6-year period, quite a lot of activity around the Caribbean, and a particularly severe event here, Hurricane Carla. Moving on again, our motivation to avoid insolvency and to allow pricing of risks. This quiet revolution developed catastrophe models. So unfortunately, to some extent, this might be the methodological shackles that bind our approach. A lot of it is, again, quite deeply empirical, based on taking a limited historical record and expanding that from maybe 50 years of data to maybe 10,000, 100,000 years of simulated events, mainly because, as we'll come on to see, what happens if a storm took another route? And we have to ascribe probabilities to these events for pricing purposes. Another approach, again increasingly to the fore with climate approaches, and this is also much beyond the insurance industry across finance, is disaster scenarios. Let's look at one particular event and consider how it could have been a lot worse. Here's just an example of the various basins here and the data sets which are collected by regional authorities that we can work with. Generally, you have latitude, longitude, time, central pressure data. If we're lucky, we can go back to 1851. This is a sort of relatively limited data that we're working with. But fortunately, it's all freely available. So let's look at Hurricane Michael from last year, a $25 billion loss to the US economy, $10 billion loss to the insurance world. So again, that difference is what's known as the protection gap. What do individuals or society have to shoulder in terms of loss? We can see here, again, from a forecasting perspective, do we know, well, this storm, where's it going to go? Is it going to go into central Miami, for example, and cause a massive, significant loss? Or is it going to maybe move out somewhere more benign or fade away? It's, 6 hours before, that's still a very open question. But here we can see a couple of footprints as we can see the arc of that storm moving across the US. And here's sort of a composite picture that we've built up of that track and that wind field. So we can see the accelerating forces, the high wind speeds here, and then the diminution as it moves across land. But clearly here, where we have landfall, we're going to see significant impact. We see a little bit of the tail of the hurricane moving out to sea. And of course, over in the UK, we're going to get sort of extra tropical cyclone activity, possibly later on, more turbulent. But again, let's look at this track. We saw it cause $25 billion of damage, but what would have happened had it moved through Miami, for example? This was quite interesting because it was the first Category 5 landfalling hurricane since that Hurricane Andrew that I mentioned in 1992. So what we can do is look to shift that wind field. We can move it in a form of scenario and estimate what would have happened had that low pressure track run through central Miami, for example, and calculate the damage. Again, we can look at the impacts of surface friction and various other factors, but this is quite a common activity to try and look at maximum probable loss, as the phrase goes. The problem is, how can we ascribe a probability to this hypothetical cyclone that we've created? Now, hopefully, maybe, this will inspire some creative thinking in the audience as to how we can approach this. And now moving on, hopefully that brings some of these points together with the former talk, but also broadens it out and allows more creativity to bloom. The topic of climate risk, the impact of Greta Thunberg and Extinction Rebellion has been significant in many ways, maybe because of people's children asking their dad or mum, what's your insurance company doing about the climate change and the climate emergency? And so there's been a significant shift in interest from a business perspective, optics, for example. It was quite interesting at the UN Climate Summit in September in New York. There was a perspective that actually there was more business engagement and initiatives than actually government-led initiatives. And my company was certainly involved in one of them. We managed to get our CEO to stand up and promote a coalition for climate resilient investment. So suddenly we're talking about broadening the need of analytics way beyond the traditional insurance world. Oh, well, the insurance folk, they do weather, don't they? There's also a little twist in that climate is not the day job of insurance. It's, what's the policy wording? It's usually annual policies. There's an idea, well, we don't need to worry about climate change. We can just readjust our pricing year on year. For various reasons, it's not as simple as that. But the knowledge of these 30 years of analytics from this even quieter revolution hopefully has broader utility for the asset management world, the banking world. And I've certainly been involved in trying to organise funding for applied research, dragging in some of these relatively reluctant players in the broader finance sector. They're certainly not familiar with engaging with research, applied research, particularly around natural hazards in that way. So let's say this coalition for climate resilient investment, a lot of the commitments from the Paris Agreement, for example, for green investment, there's a sense that the pipeline is blocked. There's plenty of money being committed, but it's not being deployed. And one of the barriers is a lack of analytics to be able to assess resilience and climate risk around various different projects. So there's talk of analytical tools required, for risk pricing, etc., and integrating climate risks into this infrastructure investment regime. So again, a non-technical world which is just not familiar with this analytics. I'm hoping that in a broader array of the business world, hopefully we can find some deeper pockets to fund some of this work. And again, I mentioned we've been involved quite a bit with the research councils and with the Industrial Strategy Challenge Fund in the UK. It's tricky. Certainly for any public sector engagement, we need private sector match funding. Equally, ideally, we need to drive transparency for some of the robustness of this analytics, which I'll comment to in a minute. We've got a very nice deadline for COP26. We've got COP25 at the moment in Spain, but in 2020 it will be in Glasgow. So again, hopefully we will have some things to show for some of these eye-catching, high-level initiatives. But hopefully, yes, this disruptive, one of those words that gets kicked around a lot. We've already had a mention of AI, machine learning. You can't move in the insurance industry for tripping over these terms. And sorting the wheat from the chaff is going to be a challenge. But I think a lot of the skills embodied in this room are required for a much more robust and demonstrable approaches to uncertainty in particular. A variety of sort of commercial activities have cropped up, climate AI, future-proof, or 27 Jupiter Challenge, a lot of them West Coast US, throwing again there's some interesting work going on there, but again, what I'm worried about here is that there's going to be a re-emergence sort of commercial black box solutions which are completely mysterious. How can we find ways to open that out and get reasonable validation, or at least some form of inspection? And I mean, also mentioning we certainly work with the Met Office in our role, particularly their product of the UK CP18 climate projection data for the UK, but there are also international, regional and global products there. Ideally, the great thing is they're peer-reviewed. That peer-reviewed information is on the web, and it gives everybody a level playing field. So sorting out that balance between private and public sector activity is going to be an ongoing challenge. One last thing I'd like to finish with is the work of a chap, Professor Tim Palmer at Oxford, who I met at the Existential Risk Conference in Cambridge a couple of years ago. And he was going, John, get the insurance sector to pay for a CERN of climate change. And that was quite an eye-catching title. Again, that aspect of resolution of the models. Tim, very keen on 1 kilometre resolution. We've already seen the consequences for that grid size at the North Pole, for example. But how can we take this exoscale computing to these problems? How can we improve some of the resolution? Because how can we get a convergence between that great sort of unified modelling done by the Met Office and the Hadley Centre to start to resolve these relatively small in time and space tropical cyclone structures? We can't really resolve them yet from a global climate modelling perspective, but maybe that day will come. And maybe there'll be, in that way, a considerable role for, again, some of the skills in this room around how can we look from a discretization perspective, how can we look at sorting out the day-to-day activity of just the weather from these rarer storm events in both time and space. But Tim, yes, we were part of a funding bid for European Union flagship, billions of euros, like the Human Brain project. Sadly, we didn't quite make it, and I believe the flagship funding project scheme is sort of in mothballs to some extent at the moment. But I think a lot of lessons were learned, and there was a lot of, it was an international coalition of people involved. But I think Tim's broadened his approach, I see from his paper this year, on, okay, ideally we could have smaller grid size for greater resolution, but also what about those sub-grid processes? We've sort of touched on that a bit. Tim here would like to bring in a more stochastic perspective on improving skill within the models, and handling some of the scaling symmetries of the Navier-Stokes equations. I leave it to the experts, perhaps a discussion for coffee time coming up around the relative merits of these approaches. But surely within this work there is a role for a more free-flowing, free-thinking mathematical perspective, because this hasn't yet been shackled, I would say, by some of the regulatory aspects of some of the more entrenched modelling. So that's a whistle-stop tour of my world. Hopefully it's tantalising to some extent, and there are some skills to be deployed there. Thank you very much.
Have you heard about shape analysis to do hurricane tracking?
Well, I haven't. No. Could you expand on that a little bit?
Well, it's
Oh.
a long story.
Yeah.
But there are some methods that
Yeah.
there are some experts in the audience,
Yeah.
let's say,
Okay.
that do these sort of things. And I've seen this hurricane tracking done with geometric techniques.
Yeah.
I don't know very much about it, but it's interesting.
Yes. I mean, I suppose I'd be quite interested in this sort of convergence of our traditional historical empirical perspective on building these stochastic event sets with more of the dynamic modelling work. That would be great if we could bring these two things together to get a bit of, sort of triangulation.
This is very simplifying. It's not solving any
Yep.
models of climate or anything like this. It's just trying to understand from data where the hurricanes are going and using some good models for that. Yes.
Oh, well, I mean, a lot of the data for the during hurricane seasons, for example, is released by places by institutions like NOAA in the US and NCAR. So generally, we are simply consuming that observational track data. I would refer to my Met Office colleagues for more of the climate modelling work. That's a good point. It has changed and improved over time. So in the past, you were lucky to you might just get a postcode for, let's say, a factory or residential properties. But now with Google Maps, Google Earth, etc., we're often dealing with latitude, longitude of individual buildings. And often you might have a portfolio of 3 million, 10 million properties or locations, for example, to process. And so there are some computational issues around speed with respect to many properties or points of risk to analyse and say, hundreds of thousands of events to get that perspective. The general metric sort of trying to get to 1 in 100-year loss, 1 in 200-year loss from that perspective. So, yes, yep. Yeah, that's a good point. The issue there, I think, moving on to the sort of investment and asset management world is because I mentioned for any loss calculations, you need input data. Getting this exposure data, asset management companies, investment folk, they don't have direct access to that. So we also need some creative ways, and there are sort of spatial finance initiatives being launched as to how we can get sort of international inventories of the built environment, because clearly there are sort of social resilience aspects, and ideally we could work with government, civil protection authorities, etc., for this sort of work.
Well, you have been talking mostly about this hurricane in the US, which we have quite a few data, and they are quite frequent, but there have been also hitting Europe. So what is the status about Europe?
Yeah, that's an interesting point, and it's this expanding the world of climate risks, because the insurance world and the notions of the policies and contracts are all based around events. And in fact, there are hours clauses in policies to define how long a windstorm is, how long an earthquake is, how long a flood event is. And of course, a lot of the IPCC work, etc., it's easier to communicate global averages around temperature and precipitation than it is to understand how, through various climate scenarios, we're going to see changes in those acute aspects. And obviously, a lot of these things are open academic questions. There have been sort of hurricane wars, as they were called, through the 90s about, are we seeing increased frequency and or severity of hurricanes in the Atlantic basin? Some of those questions have been answered, I would say, to some extent, but there's still considerable uncertainty between the different perils. The chronic aspects of heat stress and water stress, for example, to some extent they're a little easier to establish because there's much more modelled output for that. But they also need to be included in in a holistic risk perspective through some of the sort of emerging pressures to be able to disclose and report on, for example, the Task Force for Climate-Related Financial Disclosure. I mean, another aspect which I didn't touch on, generally we've been talking about physical damage here, for example, but what about systemic impacts to society over longer periods of time? Network risk. So my house isn't flooded, but the electricity substation is, or people can't get to work even though the factory is undamaged, for example, or the commercial enterprise. So there's much more work to be done there, and I think in some of these scenarios play a much greater role as well.
Yes, I think that there is also Hurricane Andrew here in UK, and I wish the king was...
Yeah, that is a tricky one. I think we call that geopolitical risk. So.